By this point, you should have a pretty good understanding of what Asterisk is and what it is capable of. You've seen how it's installed, how it's designed, and how to configure it for relatively simple calling scenarios. We've glossed over many of the details related to VoIP and dial plan configuration, but you should now have enough background for us to go deeper. In this chapter, we'll focus on the fundamentals of Voice over IP. The next several chapters cover the technologies and channel drivers for SIP, EECS, and traditional telephony, as well as 2 chapters on dial plan where we'll start to really explore the flexibility and power of Asterisk. We'll wrap up with a chapter on call queuing in Asterisk. Our goal throughout this course is to equip you with the information necessary to be an effective Asterisk administrator. Having a high-level understanding of VoIP will help you in the trenches when designing and troubleshooting your system. Without going too deep, we'll simply state that Voice over IP blends traditional telephony features and behaviors with modern networking technologies. VoIP protocols try to mimic the user experience and feature set of traditional telephony systems, despite having completely distinct underlying technologies. For example, one important difference between VoIP and traditional telephony is the way call setup is performed. In analog telephony, a dedicated circuit is established between 2 endpoints of a call. That circuit is a fixed path between the endpoints where audio can be transmitted and received reliably. If the circuit is broken or destroyed, the call is dropped. In IP telephony, there is no dedicated circuit between endpoints, and the connection is described as packet-based rather than circuit-switched. Like with any service using an IP transport layer, information is encapsulated in individual packets that are labeled with their destination. The IP network handles the job of routing those packets one by one from the source to the destination. Transmitted packets won't take the reverse path of the received packets, and 2 packets sent from the same source to the same destination may not even follow the same path. This isn't a weakness or limitation of IP networking, it's actually a strength. There is built-in fault tolerance so that if one link in the network between 2 endpoints fails, it's possible for the network to try a different path to deliver the packets. However, this can make troubleshooting issues with VoIP calls difficult because the uncertainty of the communication path. It's important to realize that VoIP is a very broad term. There are several different VoIP protocols in common use today, and for the most part, they aren't directly compatible with each other. However, this really is part of the reason that Asterisk can be such a powerful tool for PBX administrators. Asterisk can bridge calls from different protocols so that callers don't have to worry about what protocol their phone speaks or whether the person they want to dial is using a similar phone. By far, the most common protocol used with Asterisk is the SIP protocol. Asterisk provides robust support for various SIP specifications. The next chapter is devoted to SIP, so we won't say more about it here. Asterisk also implements the Inter-Asterisk Exchange, or EECS protocol. As you might guess, this protocol was developed by the authors of Asterisk, so it's no surprise that it is well supported. It also has a chapter devoted to it, so we'll wait to discuss it further. Asterisk has varying levels of support and compatibility for other VoIP protocols. There are native channel drivers for MGCP and SCCP, and there is more than one implementation of the H.323 protocol for Asterisk. These protocols are less widely used with Asterisk and are not covered in any further detail in this course. In the rest of this chapter, we'll look at several concepts important to understand to be an effective Asterisk administrator. First, we'll look at codecs and discuss what factors to consider when choosing which codecs your system will support. After that, we'll look at device naming and offer recommendations to keep your system as secure and maintainable as possible. We'll then discuss registration, which is a concept with very specific meaning in a VoIP environment. Finally, we'll talk about some common problems experienced in a VoIP environment, so you'll know what to look for if you're not getting the behavior you want from your VoIP calls.